Today we will discuss about the inverse trigonometric function. So the study of inverse trigonometric function is to establish a relationship between the trigonometric ratios of an angle and the value of the trigonometric ratio and the corresponding angle. So if you remember, in order to establish an inverse function of a function, I first need the function to be 1-to-1. That means the graph of the function must pass the horizontal line test. So let's start with the sine function. Remember, the domain of the sine function is negative infinity to infinity, and the graph of the sine function looks somewhat like this. And this nature continues, but I do not have to worry about all of that sine function. And I know that this value 1 happens at pi over 2, and the value -1 happens at negative pi over 2. But unfortunately, this function is not 1-to-1. If you want to draw horizontal lines, I clearly see that the graph of the horizontal line is crossing the graph of the sine function in more than one points. So I cannot talk about the inverse function. So what will be the remedy? So what we have decided is to restrict the domain in such a way so that the graph of the sine function is no longer the entire domain of the real numbers. Instead, what we will do, we will just consider the graph between negative pi over 2 and pi over 2. So that will be the restricted domain of the sine function. So I will say restricted domain of the sine function. So sine of theta is negative pi over 2 to pi over 2. Whereas the range, if you look at the span of the graph over the y-axis, the range of this function is going to still remain the same between -1 and 1. In that situation, if I now draw horizontal lines, I see that the graph passes the horizontal line test because the graph is crossing the line at exactly one point. So we can start talking about inverse trigonometric function. The way we are going to define inverse trigonometric function, we will say sine of theta is equal to x if and only if x, when taken the inverse sine of that, and the way we are going to write it is sine to the power -1, but we will read it as sine inverse of x is equal to theta. There is one other way you can write it. You can call it arc sine of x, and that is theta. So the inverse sine function will have the domain as the range of the restricted sine function. So it is going to be -1 and 1. Whereas the inverse sine function will have the range as the domain of the restricted sine function. So that's negative pi over 2 to pi over 2. For a cosine function, we will do similar work. So let's first draw the graph of the cosine function. And the graph is at 0, you take the value 1, at pi over 2, you take the value 0, and at pi, you take the value -1. Similarly, on the other side. But unfortunately, if you remember, the horizontal line test is going to determine whether the function is 1-to-1 or not, and this function doesn't pass the horizontal line test, as the horizontal line crosses the graph in more than one point. So likewise, in sine function, we're going to restrict the domain. And how do I restrict the domain? I try to erase portion of the cosine function. And think the cosine function's restricted domain is between 0 and pi. Now see, the horizontal line is crossing the graph in exactly one point. So that's what we are going to study now. So as we have said, for the sine function, we are going to write the restricted domain for cosine. So restricted domain for cosine is 0 and pi, whereas the range for this restriction function is the same range. It is still -1 to 1. And we define the cosine function as if cosine theta is equal to x, then we say arc cosine or cosine inverse. So cosine inverse of x is the angle theta, or as I said, arc of cosine is also theta. And as usual, we will write down the inverse cosine functions, domain and range. They're easy to understand. The domain is the range of the cosine function. So that's -1 to 1. And the range is restricted, so it's between 0 and pi. The other inverse trigonometric function that is important is the tangent function. Now remember, tangent also has this periodic nature, so we will just get one of those periods between -pi/2 and pi/2, and we will get the entire nature of the tangent function. So that's the tangent function we're going to keep. And we will say restricted domain for tangent this time is -pi/2 to pi/2. We have to be careful about -pi/2 and pi/2. These are the particle asymptotes, so I do not have any value, so they're open brackets. The range of the restricted tangent function is -∞ to infinity, because I'm assuming all real number values. So we defined tangent theta being x will tell us that the inverse tangent function of x is theta, or the arc of the tangent function at x is theta. The domain of the inverse tangent function, so domain of inverse tangent is going to be the range of the tangent function, so it's -∞ to infinity, and the range of the inverse tangent is the domain of the tangent, but in the restricted situation, so it's -pi/2 to pi/2. So that's our basic setup for understanding inverse trigonometric functions. There are some other things that we need to now understand. First, because sine and sine inverse are inverses of each other, if I do sine inverse sine of theta, I must get theta whenever theta is in the domain of -pi/2 to pi/2. If it is not, then I have to be a little careful. So what will happen in that situation? So we'll say sine inverse of sine of theta is equal to theta bar whenever theta bar is in -pi/2 and pi/2. Not only that, sine of theta is equal to sine of theta bar. Similarly for cosine, so cosine inverse of cosine of theta is theta, but if theta is in 0 and pi is the restricted domain, so we say if theta is in 0 and pi, and we say cosine inverse of cosine theta, if theta is not in this domain, so it should be a theta bar whenever theta bar is in the domain, and cosine of theta is equal to cosine of theta bar. So probably by now you are understanding why I'm using the notation theta bar, because it has to do with the reference angle in the proper quadrant. So tangent inverse of tangent of theta is equal to theta if theta is in the domain, so again, you have the restricted domain. If you know that theta is in the restricted domain of negative pi over 2 open to pi over 2 open, tangent inverse and tangent will cancel. But if theta is not in this restricted domain, then that is going to be the reference angle theta bar, when I will know theta bar is in the restricted domain, and it is such a theta bar that tangent of theta bar is equal to tangent of theta. Whereas the other way around of doing the function in the inverse, for example, if I do sine of sine inverse, it's a little easier. It is equal to x if x is in the domain of inverse. So that is in between -1 and 1. Otherwise, it doesn't exist. Similarly, cosine of cosine inverse of x is equal to x if x is in the domain of the inverse trigonometric function cosine. And tangent, because the domain is all real numbers, I actually do not worry about anything. It is x for all real numbers x. So remember, when I'm doing the inverse of sine, I am between negative pi over 2 to pi over 2 inclusive. So this is what I'm looking at. So my answers for inverse trigonometric functions are always either in the first quadrant, where sine is positive, or in the fourth quadrant, where sine is negative. If I'm doing inverse trigonometric function for cosine, then I'm between 0 and pi inclusive. So if cosine is positive, I should be in the first quadrant. So cosine is positive here, and negative values must be in the second quadrant, there where cosine is going to be negative. Tangent is pretty similar to sine, with the exception of it is not inclusive. So it's negative pi over 2 to pi over 2, but negative pi over 2 and pi over 2 are not there in the domain. So positive value for tangent will have the angle in the first quadrant, and fourth quadrant is going to be for the negative values for tangent when we are finding the inverse trigonometric functions. And there are some easier ways of understanding this thing. For example, we can say if x is between 0 and 1, so if x is in closed interval 0, 1, then sine inverse x is directly coming from the value table for the special trigonometric angles. Similarly, for cosine functions. So also cosine inverse x is the same way, it is directly coming from the value table. But if x is negative, then I have the problem is between -1 and 0. In that situation, sine inverse x is going to be negative of sine inverse of absolute value of x. Cosine inverse x is going to be pi minus cosine inverse of x. And when I do these problems, I will explain it a little better. Now for tangent, remember tangent doesn't have to be restricted. It is all real numbers. So I will say tangent inverse of x is directly coming from the table. Coming from the value table. If x is non-negative and tangent inverse of x is negative of tangent inverse of absolute value of x if x is less than 0. So as I said, there are a bunch of different rules But in order to understand and better remember these rules, we are going to start working on our lecture note. So let's go to the lecture note. We're going to skip the rules and we're going to just answer questions. So remember, the domain for inverse sine function is -1 to 1. That's where we start. The range of inverse sine function is -π/2 to π/2. So let's try to work out some problems. First one is asking me sine inverse of 1/2. So that reminds me that I need to do the table. What table? The value table for the trigonometric function. And this time only sine, cosine, and tangent are good. So 0 radian, π/6 radians, π/4 radians, π/3 radians, and π/2 radians are the spatial angles. And that will be enough for us to know to do the inverse trigonometric functions. So when I'm doing sine, remember sine of 0 is 0, sine of π/6 is 1/2, sine of π/4 is square root of 2/2, sine of π/3 is square root of 3/2, and π/2 is 1. Cosine is pretty simple because it is the co-angle. Cosine of 0 is sine of π/2, so that's 1. Cosine of π/6 is sine of π/3, so that's square root of 3/2. Cosine of π/4 is sine of π/4, so that's square root of 2/2. And cosine of π/3 is sine of π/6, so 1/2. And cosine of π/2 is sine of 0, so that's 0. Tangent is the ratio of sine and cosine. So 0/1 gives you 0. 1/2 divided by square root of 3/2 gives you 1/square root of 3. And sometimes we write it as square root of 3/3. Square root of 2/2 over square root of 2/2 is 1. Square root of 3/2 over 1/2 is square root of 3. 1/0 is undefined. So that should be enough because this is going to help us find the value for the inverse trigonometric functions. Sine inverse 1/2. So you're looking for the angle at where sine is taking the value 1/2, which is here. So the angle is π/6. My answer is π/6. That's simple. Sine inverse square root of 3/2. Well, square root of 3/2 is the value here. The corresponding angle is π/3. So that's my answer over there. The interesting thing is when you are taking the sine inverse of -1/2. What you would remember is to take this minus, slide out of the sine inverse. So write it first as minus sine inverse of 1/2. Then think about the value 1/2. The corresponding angle is π/6. So your answer is minus π/6. So let's do it for cosine. The domain for cosine is -1 to 1, and the range is 0 to pi. So again, we will remember the table and try to answer the question. First, we have cosine inverse square root of 3/2. So if I go back to my table, square root of 3/2 for cosine is at π/6. The angle should be π/6. So since it's positive, I don't have to worry about anything. I will just go ahead and say π/6. But negative means I'm going to first write it as pi minus cosine inverse of square root of 2/2. Then you go back to the table and find out where your square root of 2/2 for cosine. It's at π/4. So we'll go ahead and answer this question as pi minus π/4, which is 3π/4. Cosine inverse of 1/2, so it's positive, and cosine inverse 1/2, 1/2 is the value under the angle π/3 for cosine. So your answer is simply π/3. And again, this is because the inverse is taken for a positive number. Tangent now. Domain for tangent is all real numbers, -∞ to infinity. And the range of inverse tangent is -π/2 to π/2. Just be careful about the brackets. They are open brackets. Okay. Tangent inverse of square root of 3/3. So tangent is square root of 3/3 at π/6. So that's my answer. The interesting question is how much should be tangent inverse of negative square root of 3/3. So what I do Again, slide the minus I out like sine and write it as minus tangent inverse of square root of 3 over 3. Since tangent inverse square root of 3 over 3 is pi over 6, your answer is negative pi over 6. Tangent inverse of 0 is 0. Tangent inverse of 1, tangent is 1 at pi over 4, so this is pi over 4. But if you are to find tangent inverse of negative 1, do the same thing, slide the minus out and write it as tangent inverse of 1, so this is minus pi over 4. So let's try to find some trigonometric inverses for non-standard angles. And this time we're going to use a calculator and round our answers to 2 decimal places. And we're going to make sure that the calculator is on the degree mode, radian mode, because it is saying answer should be in radians. So first, go to your calculator, change it to radian mode. Then 0.7 is the value of the trigonometric ratio, and I'm going to find the sine inverse of that. So we'll go to trigonometry, use the second function, and then do the sine inverse. Round to 2 decimal places, your answer is 0.78. Cosine inverse of negative 0.47. Remember, if the value is negative, I write it as pi minus cosine inverse of the positive. So, in that situation, when I have that, I will find 0.47 first and take the cosine inverse of that. So, trigonometry, second function, cosine inverse of 0.47. And then subtract this value from pi. So my answer is rounded to 2 decimal places, around 2.06. The third one is cosine inverse of 3 over 7. So when I'm doing cosine inverse of 3 over 7, I'll first find out 3 over 7, and it's positive, so I don't have to worry about anything. So 3 divided by 7, and then I will take the trigonometric functions and second function, then cosine inverse. And I get 1.13 rounded to 2 decimal places. Tangent inverse of negative 14. So negative, so the first thing first, you will take this minus out and write it as tangent inverse of 14. And then find tangent inverse of 14 in your calculator. So 14, and then I go to trigonometry, second function, tangent inverse, and the answer is minus 1.5 rounded to 2 decimal places. So that thing is pretty simple. You have to be a little more careful when you are working with the repeated trigonometric values and the trigonometric inverses. For example, so the first one is cosine of cosine inverse of negative 0.4. And remember, it is saying find the exact value of each expression if possible. Do not use a calculator. Now, since negative 0.4 is in the domain negative 1 and 1, I can cancel the cosine and cosine inverse and get my answer as negative 0.4. Sine inverse of sine. So this is the time where we have to be careful. First, we need to understand, is pi over 12, is it first or fourth quadrant? If they are, then I'm lucky and I can just cancel the sine inverse and the sine. Well, fortunately, pi over 12 is in the first quadrant. So we're good. We just cancel and get my answer as pi over 12. Which is not as good when you are doing sine inverse sine 3 pi over 2, because it is no longer in first or the fourth. It's actually a quadrant angle. So this is pi over 2, 2 pi over 2, and this one is 3 pi over 2. So what you first do, you find the reference angle for this. And remember, the reference angle is going to be pi over 2. And sine in third or fourth quadrant is negative. So what I will do, I will write it as sine inverse of negative sine pi over 2. That's what we do first. Find the reference angle and use the proper sign. Now I know the minus slides out of the inverse. So now I get sine inverse of sine of pi over 2. And now see, we are in better luck because pi over 2 is in first quadrant. So we're good. And we say that Sine inverse and sine cancels, and my answer is negative pi over 2. Okay, let's do a couple more. Tangent of tangent inverse 11. So this is the situation that is always going to cancel, and it will be 11. But tangent inverse tangent negative pi over 4 is something that I should be careful about. So negative pi over 4. Think about negative pi over 4. It is already in the negative direction and in fourth quadrant. So we are good. We can cancel tangent inverse and tangent and get negative pi over 4 as an answer. Okay, now we are going to find out tangent inverse of tangent of 4 pi over 5. So let's first understand where 4 pi over 5 is going to be. So I will change it to degrees. So I will say times 180 degrees over pi. So pi will cancel. 5 divides 180 degree and gives you 36 degrees. So 4 times 36 degrees. So 4 times 6 is going to be 24. And 4 times 3 is 12 plus 2 is 14. So this is 140 degrees. So clearly 4 pi over 5 is in the second quadrant. So that's where I'm going to say 4 pi over 5 is going to be. So let's say this is 4 pi over 5. So now tangent is no longer in first or fourth. So I have to be talking about the reference angle. So the reference angle is this one, which you remember is pi minus 4 pi over 5. That's easy to calculate because this is 5 pi over 5 minus 4 pi over 5, and that's pi over 5. But second quadrant tangent is negative. So how do I write it? I write it as tangent inverse of negative tangent of the reference angle, pi over 5. So then I know that the minus is going to come out, and I will write it as minus tangent inverse of tangent of pi over 5. But pi over 5 is now in the first quadrant, so I can cancel the tangent inverse and tangent, and my answer is minus pi over 5. Alrighty? Sine inverse sine of pi. So think of this. Pi, the angle, is here. It's in the second or the third quadrant. So I have to find the reference angle clearly because it is on the negative direction of the x-axis. The reference angle is 0. So I will say that this is sine inverse sine of 0. Now sine of 0 is 0, so I get sine inverse of 0, which is 0 as my final answer. Sine of sine inverse of pi. So before we cancel sine and sine inverse, we need to make sure whether pi is in between negative 1 and 1. But remember, pi is approximately equal to 3.14, so that's greater than 1. So I get to say pi is not in the domain negative 1 and 1. So this value does not exist. The one other variation of this type of problems are finding the trigonometric ratios of the inverse trigonometric ratios, but the trigonometric ratio and the inverse trigonometric ratio are not necessarily the same. And doing these problems, we have to heavily rely on sketching the graphs. So this time you're taking the sine inverse of 24 over 26. Since it is positive, I must be in the first quadrant because negative sine inverse will be in the fourth quadrant. So I will say this is the triangle in the first quadrant. Sine inverse, so sine is y over the radius r. So y is 24, radius is 26, and I do not know the x. Okay, so think about this as finding the value of x. So x square plus 24 square equal to 26 square. So let's use our calculator to find x square. 26 square is 676. So x square plus 576 is 24 square is 676. So x square is 676 minus 576, and that is 100. Then I take the square roots on both sides, so I get absolute value of x equal to 10. But because x is in the first quadrant, it is positive, so x must be 10. And remember what I'm finding. I'm finding cosine. cosine of theta is x over r. Now you know x, that is 10, and you know r, that is 26. So that's your answer. Probably you would like to simplify it as 5 over 13. Okay. Now I do tangent of cosine inverse of negative 10 over 26. Now cosine is negative. So because the range of cosine inverse is 0 to pi, the angle must be in the second quadrant. Positive means first, negative means second. So that should be my triangle. Cosine is x over r. So x is negative 10, r is 26, and I need to find y. Now I remember from the previous calculations, y square plus negative 10 square should be 26 square. So y square plus 100 is 676. That means y square is 676 minus 100, which is 576. And then you take the square roots on both sides. But remember, that will be absolute value of y equal to 24. Because y is in the second quadrant, it is positive, so y should be positive 24. And I wanted tangent of theta, and remember tangent of theta is the ratio of y over x, so you get 24 over negative 10. Simplify and write the minus in front, so you can divide both top and bottom by 2 and get negative 12 over 5. Secant of sine inverse of 1 over 6. That's what I'm going to find out now. Again, it's sine inverse negative, so I should be in the fourth quadrant. Sine is between fourth and first. Inverse being taken on the negative number, it's in the fourth quadrant, so this is my triangle. And again, sine is y over r, so y is negative 1, r is 6, and I want to know x. So x squared plus negative 1 squared equal to 6 squared. So x squared plus 1 equal to 36, means x squared equal to 35. I take the square roots on both sides. So I get absolute value of x equal to square root of 35. But because x is in the first quadrant, it is positive. So x is equal to square root of 35. And I wanted to know secant, and secant of theta is r over x. So this is going to be 6 is r and square root of 35 is x. So that is your answer. Now, if you want to rationalize, then you will multiply square root of 35 on top and bottom. So I get 6 square root of 35 over 35. The next problem is pretty similar. Instead, this time we do not have only number, we have numbers and letters together. So use a right angle triangle to write each expression as an algebraic expression. Assume that x is positive and that the given inverse trigonometric function is defined for the expression. Since x is positive, all these inverse trigonometric functions are positive, so they are in first quadrant. That's the nicest information. And remember, you are doing cosine inverse 5x in the first quadrant, so that should be the triangle. But cosine inverse 5x, you can think of that as cosine inverse 5x over 1. And this is the x coordinate over the radius. So the x coordinate itself is 5x and the radius is 1, and I want to know how much is y. So I would say 5x whole to the power 2 plus 1 squared is y squared. So 25x squared plus 1 is y squared. And remember, I'm trying to find out y. So I take the square roots on both sides. So I get absolute value of y is square root of 25x squared plus 1. But because y is in the first quadrant, it is positive, so y is simply square root of 25x squared plus 1. And I wanted to know tangent, and tangent of theta is y over x. So now I get my answer. My y is square root of 25x squared plus 1, and x is 5x. So that will be the trigonometric ratio. Sine inverse 5 over x. Again, x being positive, 5 over x is positive, so we are in the first quadrant, and that is my triangle. Now remember, sine inverse is y over r, so this time the r is actually x and the y is 5, and I want to know how much is this coordinate. So I will say this coordinate squared plus 5 squared is equal to x squared. So the coordinate squared is equal to x squared minus 25. If I take the square root, I actually get the coordinate equal to square root of x squared minus 25. To be more specific, it's absolute value of the coordinate, but since the coordinate is in the first quadrant, it is positive. So the coordinate is square root of x squared minus 25. And I wanted cosine, and cosine of theta is going to be x over r. Remember, x is this much, which we found as square root of x squared minus 25. And the bottom should be r, and we found that the r is the variable x. So it is that. Answers my question. And this is pretty much what we wanted to do in our class today. That has given us some idea of the inverse trigonometric function. Again, it will make way better sense if you start working on the homework problems. If you have questions, let me know. Otherwise, we are good today.